So for the benefit of the recording, we're going to take a look at the final set of notes that I've been typically provided for, I provide for this, which is the interaction with systems. Now, I am totally aware that for some using Horizon, you'll have difficulties trying to get this running. So I totally understand that. I want these notes to be there just for your information. So what I'm really trying to say is on the assignment, I probably will not be able to mark for interactions like this, but I do want you to see it anyway and the importance of doing it and the benefits of doing this. So I'm just going to go on to my downloads. Under my downloads, I've downloaded what I call the Student Pack Lesson 5. If any of you have already used this, that's fine. Now, the one thing that I didn't cover with you before is what if you're wanting to API an already made component? What if you're going to API something like an engine block? Because you would not API an entire build of an engine block. If you were going to API something like a piston, so pistons, for example, have 268 profiles on them. Each profile serves a particular term for the role that it's actually running in. So the engine that it runs in is designed to operate the best in that condition. So you wouldn't simply just API that process. It's a monstrous tool. So what I'm going to do is just going to highlight all of the aspects in here. And in this example, what I'm going to do is I'm going to automatically bring in a part. So these are the two parts, and I know these are simple parts. In reality, you probably would not API these. I mean, you probably would not bring in these parts automatically, but I've kept them small just so that we can easily move them around. So in my beam section here, what I've actually got, 2 seconds, it's appearing on the other screen. What I've actually got is these criteria. Now, for anybody who's unsure where these values came from, these are just ones I've made up. They're nothing special. So these are just values I've made up, and you'll find these in the notes anyway. But I've just given you these, and what I'm going to do is I'm going to open up SolidWorks. I'm then going to get SolidWorks to open up the Excel spreadsheet, read from the Excel spreadsheet, take values from there and place it into the variables. Now, a benefit of being able to do this and a reason for being able to do this is, industry example, most people who do these VBA codings or these GUI codes, they would prefer people did not touch their code, because if you've got somebody who claims to know what he's doing and he comes in and he messes with that code, it can damage a whole process. So what people tend to do is either put it in a text file or they put it in an Excel spreadsheet and let the system read from it. So for example, let's say if somebody comes along and says, look, we're now producing a new I-beam, add a new column. That's all they've got to do is add a column, and that's it. And if something goes wrong, what you do is you go to the column. You don't go to the actual person who did the API. Minimizes possible aspects of things going wrong, really. So I'm just going to snap it into the edge. Come into here, and I'm going to go Edit, into my new folder, and there's my Excel beam. 2 seconds, let me just double check something. Last year I realised I put some massive answers on here, and I just want to make sure I've not left them here. Oh no, I've not. Excellent. Right. So, again, I'm putting this on here because I do want you guys to be able to see this and get an idea of what this does. Now, if you remember, in the other stuff that we've done, what it does is it records the new part. It brings in the new template, the address to where that new template sits. What I'm looking for, well, what I wanted to do is I wanted to not bring in a brand new part, but bring in a pre-made part. So in this case, it's actually the I-beam. Now, the one thing that you do need to keep in mind here is this is an address. This is the exact same thing as what we'd seen when it was bringing in a new part. So what I've got to do is find that new address. Now, luckily, obviously I've done this for years, so I know exactly where these addresses sit. So a quick way of finding where this address sits is simply right-clicking on the I-beam, going down to Properties, and there is the address. So that's the address, the location of where it's presently being stored. So all I'm going to do is simply copy that. And then here, you must keep this in mind. So if I just make a little bit more space to show you what I mean. Paste that in there. What you'll see is you can see the drive in which it's stored. You can see the user that is active. You can see the name of the user. You can see the location within that user's account. And then you can see the point in which the location is loaded to. So it's from the C drive, it's users that are there, it's myself, it's on the desktop, and it's in a new folder. So that means if I trace back along here, it's the F drive, it's the lecture notes that I've produced, it is the module code that I use, it is the semester, then it's in lesson 5, and then it's the part. Now you see there, that means that I need to keep that. Yes, so that's, yeah, exactly. So if anybody's not seen the chat, the question is about, do we have to change the location? We do, and that's what I'm doing, but you're absolutely right. Now a key thing in the assignment to be thinking about is, if I need every assignment that I get in, I will have to change the location. However, there is some very sneaky ways of getting it to automatically find that location every time. So I know how to do it, but I don't show anyone just because when you get that working, it is such a feeling of success because it works. And it's not a big thing to get working. Well, it is a big thing to get working, but it's just that point of just really getting at it. So what I'm going to do is I'm going to delete all that out. So you see now, that is technically the location for it. Now I do want to come back because I'm still not quite done on here. So if we go set part, we know set part is going to set up what our active piece of component will be. So this will be maybe a new sheet, maybe a new template, whatever it is. Now what I'm going to do here is, when it comes in, it looks, you see in here it's in quotation marks, so that refers to an instant address. So that's the address of where it's presently stored. I do want to keep reiterating that for that reason. And to show you again where I got that location, if I come back onto here, this is my new folder. If you remember, I downloaded this, put it into a new folder, right-clicked on it, gone to Properties, and boom, there is my folder location. Minimize there, and that is my present location. Now then what we end up with is it looks for a Boolean response. It looks to know, is it going to become active, and we give it a key marker as an active. So then what it knows to do is fire it up, not just hold it in the background, because that is interesting. Because what's interesting in this example is that we're holding the live part in one position, and then we're going to hold an Excel spreadsheet. We're going to open Excel, but we're not going to have it up on screen. We're going to have it hidden in the background and just feed from it whenever we need values. So if I come back into the next process, now somebody said to me before, Excel object. Is that an important name to give it? No, it's not. It's just one I use just because I forget. I look down and go, what was that again? So if I scroll back up, you'll see here, dim Excel object as an object. So I could call it MS Excel. I could call it anything I wanted. But Excel object, it just lets me know that it's a genuinely one that I'm doing. Now, this is a good process. So if we start again, we've gone from setting SolidWorks as the active application. Then we go to bringing in a new part, which in this case is a predefined, pre-made part. We'll take a look at that part in a minute because there's a few extra things on there I also want to show you. Then from there, it goes to Excel object, and it says get object. Now, for those of you who do microcontrollers, for those of you who do any C programming, C Sharp, anything on these forms, what you'll know is get object is when you're relatively operative within one particular area, you get the object to bring it in to your present area of operation. So all we're actually doing is we're grabbing our Excel spreadsheet and bringing it into the file location that we're going to operate with. And all we're doing is we're holding it there. We're actually doing nothing with it yet. However, that next process, what we really need to do is we need to activate it. So if you see here, we set that as SolidWorks is active application. Now, when it comes to here, we set XLS, Excel object dot. Now, the Excel object dot is the exact same thing that we did with the user forms. What it actually does, comes onto the Excel object, goes dot, and it says this is the different things that I can do with it. The active sheet means, you know when you first open Excel and you get this sheet, that whatever that sheet opens to, that is what it's going to operate to. You can navigate throughout sheets. I've never really found a real need to do that, but you can navigate throughout sheets. Oh no, we'll keep going. So obviously we've got a send message to user, welcome to iBeam. And then, just for a little bit of fun, I put in enter your beam capacity required in newtons, and I just put some defaults on here. And then enter your length required in meters. And then all I've done is force times length over 4. And then what we end up with is a ratio value for our used output. So now what I do is go to fit is equal to false. Now fit is equal to false in this case becomes a Boolean status. All this is actually doing now is it's a true or false, that's all. And I use it for an on and an off. This is because in this while loop I have 2 tests running. And these 2 tests are a few things. Now I'm going to try my very best to show you why there needs to be 2 tests. So if I come back onto here, let me go on to Beam. Come to here, snap to there. There is a key reason why I'm going to do this, and I'm hoping this is going to explain quite well. One can hope, one can hope. So there we go, right. So if we come on to the actual test here, we say fit is equal to false, we say column is equal to 2. So I'm going to relate this back. One thing to keep in mind, we have naturally taught ourselves to read in columns and rows. So you know when if you're talking to someone about Excel, you'll go, oh yeah, it's in B25 or B10. It's actually it's actually seen in rows and columns. So row, column. So the reason I want to take you through that is just because when we go to this section here, you'll see it. So what we do is we go into the while loop, and it says in the while loop, I'll extend this back out and I'll snap it back together in a moment. So it comes into the while loop and it says while the Excel spreadsheet at cells row 9 column 2 is not equal to this. This is mint. This little tool is phenomenal. All that actually means is an empty cell. What it's actually saying is keep doing whatever you want, whatever you're doing, until you find an empty cell. If you find an empty cell, this while loop is actually no longer true. So what you're saying is while the Excel spreadsheet at row 9, column 2 is not equal to an empty cell, do the actual test. So if we come back, what it's actually saying is row 9, column 2. So it's starting there. If it's not equal to an empty cell, then do the test. Otherwise, stop. But there is a catch with this. It looks dead slick and it runs really well, but there is a catch. So what we've actually got to do is put a double loop in. Now this is purely because let's say we find the value. Let's say we do our test here, which I'll get to this test in a second. But let's say we get to that test and we find the value and we go, yep, that's the value that we want. And we're going to extract these dimensions to go into the geometry. Because the way that this is set up to look for an empty cell, all it will do is go, that's good, and just keep counting along and count along. So what we've got to do is give it another reason to stop. So this is why we have two testing elements in it. We have, while the Excel spreadsheet is not equal to an empty cell, and fit is equal to false, which is our Boolean way of being able to sort things out. Apologies, I just realised that the signal may have gone bad for a second. I'm just going to turn my syncs off. I think that should have helped. So now what it does is, so we have our key two tests within here. We have our Excel spreadsheet, row 9, column 2 is not equal to an empty cell, and fit is equal to false. So max BM, now if we come up to here, you can see here, max BM is set as a double. It's just me, it's max beam, that's all I meant. So when it comes up to here, if max BM is greater than or equal to M, so if greater than or equal to our calculated value, if it's greater than or equal to, then go to fit is equal to true. So it then changes this over, and location is equal to location column. Now, I want to step through this to try and show you guys why. Because if you remember, when I was doing it the other week, we did for loop, which would just stomp through, go 1, 2, 3, 4, 5, and stop. But with this, what it does is it runs down and increment one value extra. So if we go to here, for example, if it comes out, it'll always go to column is equal to column plus 1. So let's say we finished on column 2, and we've met it. This if statement became true. We finished on column 2. It'll come to here and go column 3. So it'd actually shift that value. So what you do is you record column before it gets changed. So location column becomes our new value to measure against. I will step through this and you can see that count, but that's an important thing within it. If the if statement isn't true, what it does is it misses out the if statement. In fact, let me just see if I can tab that up. And put you one more. So what it does here is it misses the if statement and then simply goes to column is equal to column plus 1, then shifts it to another one and then checks the other. Now I'll show you. So if we come back onto here, it runs down, checks max BM. In this case, B9 is our max BM. If it is not greater than or equal to, what it does is it goes along and checks again, is it greater than or equal to? And if it still isn't, goes along, is it greater than or equal to? And if it still isn't, what it does is it gets to the end, and then this becomes an empty cell and stops it anywhere. So there's two ways of being able to dive out of this. From there, fit still remains false, and it goes down to here, and it just says there is no standard section strong enough to support for this situation. And oh, that I've just realised that is in the wrong spot. That should be sitting there. In fact, I have no costing value still on here anymore. In fact, I'm going to comment that out. Let's comment that out. Right. However, if it is true and fit becomes true, if fit is true, then what it actually does, I do have costing there, silly sod. What it actually does is it takes the length and then works out based on my very cheap values. Now, a lot of students have given me so much crap over the years over the lengths and pricing on these. They're like a tenner for like 3 meter I-beam made of steel. It's very cheap. It is in my shop. Anyway, so what it then does is it goes to part parameters. Now, before I run this, I want to take you through this next key process with this. So I'm going to minimize this. One impressive example I had of this one is a student brought in the Formula student car. The API'd the car being able to move in different scenarios and different criteria, which was amazing. I'm just going to go open and come to my API. So this is the beam that we're going to open. Again, I know it's dead straightforward, but this is the beam that we're going to use. So if I then open the SketchUp and go edit to the sketch, and you look, you go, yeah, okay, but I'll come down to here. Are my dimension names on? There we go. So you see there, the dimension names have already been defined. If you've done dimension names before, that's great. If you've not, please do let me know and I can help you with that. But what you'll see here is under these these dimension names here, what you'll see on the actual piece itself, it refers to these dimension names. A great reason for doing dimension names is it's easy to navigate around when you want to know where you're going or what it is that you're changing. Or else you end up just getting D1, D2. Now, if anybody's interested how to actually get them dimension names, let me turn it on. Go view. I'm just going to turn on all the stuff so we can see it. It's okay. I'm going to do this process, and for those who have never done dimension names before or ever seen dimension names, I will show you how to do it. It's not a big thing. It's if you've just never seen it though, it makes things a little bit more tricky for you. I forgot to turn my bloody displays on. Where are we? Hide and show. It used to be so easy to find these. Anyway, I tell you what, I'll just do it the normal way. If you wanted to know how to do it, if I go record, and I'm going to edit flange. Change that to 10 and then click OK. Stop. Let's call this dummy. Again, in this example, you wouldn't really API something as simple as that. It would need to be considerable geometry as to why you've done it, or else, yeah, you instantly come away and go, why would you do that? That was my bad, holding it up with the wrong way, schoolboy error, and there it is. And it's simply that one. So if I come back across, you can see here my flange sits there. If you've never done naming of sketches, don't worry, I'll take you through that process, so at least then you can see it and how it's done. It's not a difficult thing, it's just if you've never seen it, you've never seen it. So I can take you through that. The other thing is, if you are following me with this, do not leave Excel open. I'm just going to close that. Do not leave it open. The other thing you do need to keep in mind is if you do intend to start playing around with interactions, we're going to open up Excel and keep it hidden in the background. If you do that, you must always make sure that you turn it off. So you'll notice down here I've got Excel object application alerts equal to false. That is, you know, when you go to close it and it says, do you want to save? You go, no, I don't. That is turning off that ability for it to ask you. and then you go to application.quit. If you leave it open, you do risk spamming your PC. You do risk it slowing down drastically, so you must make sure you turn it off. The other thing is that I've just noticed is, you know how we changed the address for the actual part? I didn't change the address for the Excel spreadsheet. So that was the address to where my new folder is, so this folder. So I know from that this location to the Excel spreadsheet is still going to be the same. So I'm just going to comment down here and then paste. Still the same location, and what I'm going to try and do is see if this will now work. I just realised that might be an old file extension. I'm sure it was XLSX. 1 second, let me just double check. Oh no, XLS. Ignore me. So right, I'm going to step this F8 into submain, SolidWorks applied, open new part, parts brought in, import Excel spreadsheet. That freezing is Excel being open. If it works, it'll come back to. If something's gone wrong when you've clicked step between Excel object and XLS object, activate the sheet, if it doesn't freeze for a moment, you've done something wrong. Because what it's trying to do is it's opening up Excel in the background. So if I go F8, run it again. Welcome to IBM. Happy days. Enter the newtons in capacity. I'll go 250. Not much. Enter the length. F8. Go 2 meters. And now we have 125 newtons. So it runs in. Column is set to 2. Max BM at this case is 300. It was obviously going to jump straight out. Should have made it bigger. Max BM in this case is 38,467, and it's now set at row 9, column 2. Checks to see if max BM is greater than or equal to. It is. So then it runs into the if. It makes fit equal to true. Now, do remember at this point, column, I need to record column as being column 2. So if I step down, column is still at column 2, but then if I come back out, what the while loop needs to do is go back to the top to check to see if it's true. It runs into here, still follows through with this code. So now column is equal to 3. This is why I needed to assign location column. If I didn't, I would be looking at column 3, not 2. Run back in, fit is now equal to true, so this is now void. I go to fit, fit is now equal to true. Right, and now what it does is it goes to my Excel spreadsheet. At row 10, which is the bottom one, it's then going to take it from, oh, look at that. Oh, that's an error. That should be a location column. Oh, that's awkward. That's the wrong price, even though it's stupid pricing anyway. Then what it does is it takes it from, let me jump this back up. It comes down to here, takes the system value, goes to Excel spreadsheet, row 5, location column, which in this case was 2, assigns that. Row 6, location column, again, equal to 2. And then 7, repeating the same process. And then 8, repeating the exact same process. And then L. And L in this case is what the user had predefined. And then this does the all-important force rebuild. If anybody's unsure about your force rebuild, it is your traffic light system. It's known as a force rebuild, but it's the traffic light system. I know in Inventor or in Fusion you end up with a little lightning bolt. It is a force rebuild, but I don't know what its actual technical name will be. So you get your force rebuild. It then does a zoom to fit, brings it back out, and then the cost is 25 quid. Yeah, I need to really fix them costs because they're definitely not that. Now this is the important bit. The Excel spreadsheet runs in application dot display alert is equal to false. Excel object dot application quit. So turns it off and then quits Excel and then closes it down. So let's come back to the actual part. And that is what it generates. So, and that is what it generates. And again, I do know that you wouldn't do this for an iBeam. You would probably API this just as quick. For the next assignment though, pick any parts that you like, any parts at all. I've had valves. I've had. Well, do be cautious though. Some of the hardest things to do are things like sprockets, gears, sprockets. They're tricky. They're not impossible, and they're very impressive when they work. Really impressive when they work. But they are tricky to automate and get them working successfully and how you want them to. It does involve an awful lot of maths to get it running smooth and to get it running how you want it. But it is so worthwhile at the end of it. They do look very impressive, and they do operate very impressive. So if you are a mountain biker, if you're anything like that, you're welcome to do any key components. Pick anything that you want, but do pick something with relative depth to it. So I had a student before who said, "Can I do an iPhone maker?" You go, "Well, it's a box." If you do something like that, I want exact precision of key mounts. I want all precision inside sockets. I want the connectors. I want the screen dimensions correct. I want the housing to be correct. I want the camera to be correct. It all needs to be accurate. If you can't get the values, then just don't do it, because you're going to introduce so many problems for yourself. You're best picking something which is a little bit more easier to approach. Right, so that is, now there's two sections of this. Now I'm going to break this into two pieces really. What is that? There we go. So I'm going to break this into two pieces really. What I'm going to do is I have a challenge. For those of you who have been able to just follow me with this and go through this key process, I do have an extra challenge. Before I move on from this, is there any key burning questions? Let me just tab this along. Just wanting to make sure it's a bit better in its appearance. Let me just go to that. One second. That's the only reason why I had not done that as of yet. Sorry, just more questions coming through. Oh, good question. So, human body bits. So things like braces, AFOs, things like that. That is one that you could do, yes. However, it is specific that I'm looking for. So with this, it would be more of an accurate representation that I'd need to find. But again, I'm going to release this on the assignment throughout. Once I get this deadline right, you'll find it on Blackboard before I actually give it to you. But then I will formalise it next week anyway. But yes, you can do that if you wish. Right, so that is one that I would recommend that you have a go at and do take a look at. Previous lecture recorded had no audio. Is this from last week? There was two from last week. So the is that both of them that had no audio with them? But anyway, because in each one, what I attempt to do is do the same note example, but just in a different way. In this example, we won't be doing any different with anyone, because there's really key learning from this that I don't tend to really mess around with. So let me just double check. Okay. I'll take a good look back over that and see if which ones have gone a bit belly up, and I'll try and reproduce it. Again, the two lectures that are there, they are the same but in a different component. But I appreciate if you're forming a component development and you're thinking about the Mondays one, you'd want that right anyway. So yeah, I'll get that fixed up. So there's two things here. For those of you who've never done dimension names, if you've never done it, you've never done it. It's not good or bad. It is just what it is. I'm going to take those who've never done this and just show you how this is done. You don't have to name things. You don't have to. It can be useful, because if you're wanting to, if you have something, I don't know, with 500, 600 different dimensions, if you have just an indicator of what these things are named, it makes life so much easier. For those of you who sat Tony's MP2715 last year, you'll know this inside and out, because I made sure he forced it down your throats, because it is a really, really useful thing to know how to do it. So for those of you who've not done it, I'll do it in a second. For those of you who've done it, who are laughing to yourself because you're so confident, I've got a challenge for you. Right. Is it here? It should be here. Let me just see. Oh, look at that. I don't have it here. Oh, that's awkward. Why are the bolts not there? Oh, hang on a second. I have some supporting bolt to go there. I just need to double check what I've done with it. This bolt is a challenge that is in the notes. Ah, silly sod, I didn't turn it on. So on Blackboard, for those of you who want to challenge, the bolt is there. And the challenge is with this bolt is you have two dimensions to work to. Let me open up the bolt, show you the actual piece. So this is the bolt when it loads. So this is the bolt. Basic example. But what you've got to do is control two dimensions. You've got to control length and its overall width, and you've got to get everything else to adapt itself around it. So in this case, now what you're actually doing is you're not just doing one dimension anymore, you're actually doing two. So you're controlling two variables based on values that are being fed in. I have just freed up the bolt as an example, which is here, and that is broken. It does not work. It does require fixing. So if you've done this, please do open that up and get used to it. If you've never done a dimension naming, don't worry, I'm going to go through it right now with you. Before I do that though, is there any burning questions about anything else? If anybody does need to speak to me about assignment wise, things like that, I can speak to you, don't worry about that. But yeah, you will just need to let me know, just because my time seems to be getting skinnier and skinnier the older I get. Right, so again, so if anybody is done dimension naming before, please do have a go at the bolt. The supporting code that I talked about is actually sitting here. So that's the supporting code, and I've just freed it up. It's just on Blackboard right now, so do have a crack at it and see if you can get it working, because that's the ultimate test. Right, so I'm going to close this and close this. So I'm just going to start off with some basic components. Often just having the most basics of things and looking at how these things are defined makes life so much easier. So what I like to do is I'll go View, Display, Hide and Show. I see here I've got dimension names. I'm going to click onto dimension names. What else do I want to show? What type of customized menu? No, I don't. That should really do it. So what I'm going to do is go up to my eyeball for hide and shows, make sure everything's turned on, because I'm never quite trustworthy of some of it. It'll say, oh yeah, it's turned on. You go, well, where the hell is it? Yeah, dimension names. So with my dimension names turned on, I'm going to go to top plane, and we're not doing surfaces for this assignment, so I'm just doing simple volumetric geometry right now. So let's say I need a dimension on here, and what we'll do is we'll call this, let's call this dia. Oh, hang on a second. Sorry. See here, we've got D1 as sketch 1. What I'm going to do is call that dia. See there, it's got a dia at sketch 1. So I'll put this to 80 millimeters, and then OK. So then you'll see here that on the right side, it's instantly marked as dia. If you are going to do a lot of automation on these types of systems, if you are going to increment an automated method, using the named dimensions saves your ass big time. So what I'll do from here is then go extrusion. And come to here. And then I will click onto OK. Where the hell is that? You sort of just click these, I swear to God. I can never seem to get that bloody thing to reappear. There it is. It's often fiddling around and fiddling around and fiddling around and fiddling around to actually get it. And if I just click back off, show you what I was doing. If you left click on, and if I left clicked over there and you left click there, if you left click again, then again, it's just get this. There we go. So I've double clicked on the actual face, and that's what it does. Come back. That's it. So we double clicked on the face, and there is the height. Now you see there on my height, on the left here, I've got D1 at boss, so I'll just call this H for height or whatever really. So if I click back on, whoops, click back on, see there it's on D, see there I'm on my dia sits there, and there they are. There are my named dimensions. Now if I record myself changing them dimensions, what it will do is it will record the name, and it will also record the value. For those of you who use ANSYS, you'll know that ANSYS prefers to tell you the names first and then the dimensions, but with this system it prefers to give you the values first, because it's a CAD system. It's what you'd expect. It prefers to give you the names first. It prefers to give you the values first, and then the names it tends to hide, because it doesn't really see a point in using them all the time. If you're doing anything like design tree, if you're doing anything like configurations, what we're talking about doing here makes it that little bit more flexible. So design configurations by design, they are a little bit more restricted. I do find this way more flexible than what Inventor's way is, if I'm honest. This way does have a lot more freedom, because you can code purely from scratch as far as this type of thing goes. So, is there any questions on that? Is there anybody that wants me to just go back through that again? Just checking. Okay, brilliant. So again, that is your dimension naming, and I would recommend that you practice at that, get used to using that. It is a really useful tool, and if you're wanting to bring in geometry and you're wanting to automate that geometry being changed, so if I was to automate on this geometry, again, all I would do is go record onto my height. Let's change that to, I don't know, 80. And then change that to 50. Now what you see is nothing's really happened with it. It needs that force rebuilt. I do rebuild. And then I'll do a zoom to fit. And stop. Put it into my dummy. Click OK. Oh, sorry. Oh, right. Pop over there. Pop that over there. And then let's come into that dummy. Back onto this dummy. And you see here, I've got all these extra bits, so I don't need all that. And as ever, I don't need them. And what we got is the 80 and the 5, so let's go back to 100. And then let's go to 40. So that running again. And it just automates itself that way. And don't get me wrong, I know this is a shaft, but this has its ability to be able to speed up processes drastically. If you're operating on something where there are key things that really refine what you're trying to do. So, for example, if you're talking about shoes, if you're talking about key elements of them shoes, because they don't simply just scale in all their directions, they need to they won't equally grow in their own different shapes. They'll be similar. They'll be similar, but you end up with a variation in different lengthing. So what you end up needing to do is to get everything else to operate around that. So this is a great way of doing that. But yes, that is as simple as, and it's as simple as that. I can simply take these values now and I could build these into an input. I could get the user to input and I could start to refine that, tidy it up even more, and get that running really, really slick. But yes, something like a screw you would not model from, you would not import. There'd be no point. It would be a waste of time, and you would lose marks on something like that. So importing a screw, a nut or a bolt, or an Allen key, or a screwdriver, it would be a waste of time. So you wouldn't with that. However, if you've got something with a lot of geometry on it, landing gear, for example, you sure as hell would not automate that process. You would import that model. So there is a balance. And so I don't want you to think that for your assignment it would be more than acceptable to just simply import a rivet. Because you just wouldn't do it. You'd speed it up. It's much quicker to actually code it. So springs, screws, nuts, bolts, they all fall under the remit of needs to be modeled from scratch. Something like suspension, a full suspension, alloy wheels, anything like that, that would be something you would import due to the actual geometry levels and the amount of stuff that you have to do to it to get it working. Do keep in mind though that a poorly designed model will not API very well. So if you, let's say you went onto GrabCAD and you found something and it was, I don't know, a Ferrari, and you thought, right, cool, I'm going to API Ferrari, that'd be awesome. If whoever did it was a bag of crap when they did it, automating that is a nightmare. Because think of it like this, those of you who've used SolidWorks through and through, you'll know if you change something slightly above, everything goes bright red instantly. But if you've designed your process very smoothly, what it will do is it will move nicely with it. So if it's been done badly, it will just, in lack of better words, it will just shit itself. If it's been done well, it won't. It will do really well. So these are some things to keep in mind. Again, what I would say from this point now is do have a look around. Have a look at some different geometries. Have a look at something that you want to have a crack at. This can be anything that interests you, but it must be accurate. There is no, I mean, there's some levels of things that we can accept. So, like, for example, let's say you get some of the dimensions from a key nut and bolt set, but some of it you can't find. I will accept you filling in the blanks there. It's acceptable. But if you just BS right from the start and go, no, it was this big, you kind of go, no. I need to be able to follow that process with it. So these are these important things to remember. But yeah, do have a look around. I will be releasing the assignment. I just need to double check for releasing for the resets, and I just need to make sure that I'm going to be giving you enough time. It's just because I am going to try and run this right up to the end, and this is what I meant. If anybody pushes past that key point of extensions, then you'll be into resets, and then that will be August. Again, you won't be capped, but it will be into August. So it's just so you know. And then it allows me to draw a line, and for those who are up to speed with their assignment, I can give you your feedback. Those who weren't, which, you know, it's not your fault, I understand, you'll be going into the resubmissions. It's not resits. It is like a resubmission section, but you won't be resubmitting. You just be doing a new assignment. You just missed that deadline. And yeah, so this should be out. This will be out this week. I'm also going to start uploading extra videos I did from last year. One was the process of automating a stepper motor. Different stepper motors, different designs, and getting that to flow through. The other one was the spring washer. I'm going to upload the spring washer. I'll put it all onto Teams because it just seems to be a bit more accessible. Take a look onto that, and these are all just different ways to automate. Other than that, I'm not going to do much more than that. That's pretty much me at an end, really. What I will be doing is all the little bits of different challenges that I did set you since we've been going through the coding. I'm going to group them all together into one chunk. Also, with the assignment, I like to give you little things called useful small programs. I don't tell you what these are for, because in my mind, what you're going to do is you're going to leave on here, go on to forums, which you should, because there's very little guidance when it comes to this. Go into forums, look at different communities, and you'll find little snippets of code, and you kind of go, does that work? Does it not? So what I do is I produce something called useful small programs. I know they're useful, but the question is, can you figure out how they're useful? And that's the same type of thing that you're going to get from forums. I just wanted to speed up the process for you. Other than that, what I'm going to do in just a moment is I'm going to put myself onto mute. I am going to remain here for the next 10 minutes. You don't have to hold on any longer if you don't want to. If there is any burning questions, please do fire away. But for that is this section of that pretty much done. I'm going to stop the recording,